Hello, it's GCSE Physics Explained. This video is about magnetic forces. Learning objectives. Know what the motor effect is? Know the factors that affect the size of the force on a conductor and how to calculate it? Know how to use Fleming's left-hand rule to represent the directions of the current, the magnetic field and the force. Remember, from a previous video, I explained that when a current flows through a wire, a magnetic field is created around the wire. If you now take that wire and place it into a magnetic field, interactions between the two magnetic fields cause magnetic forces, which can cause the wire to move either up or down. This is called the motor effect and is summarised like this. When a conductor carrying a current is placed in a magnetic field, the magnet producing the field and the conductor exert a force on each other. The force on the wire and the force on the magnet are equal in size but opposite in direction. Factors affecting the force. The size of the force is affected by three factors. The magnetic flux density, which is a measure of the field strength. The size of the current. The length of the wire in the magnetic field. Calculating the force. Those three factors are used to calculate the size of the force using this equation. Force on conductor carrying current at right angles to the magnetic field in newtons equals the magnetic flux density, sometimes called the magnetic field strength, in Teslas or in newtons per ampere meter, times by the current in amperes, times by the length in meters. We usually just say force equals magnetic flux density times by current times by length, or we just say F equals bill. Here's a typical question for you to try. A 2 meter long wire runs at right angles across a magnetic field with a strength of 0.4 Tesla. Calculate the force on the wire when the current is 0.5 amps. Pause the video and have a go at answering. Here's the answer. Force equals magnetic field strength times by the current times by the length equals 0.4 Tesla times by 0.5 amps times by 2 meters equals 0.4 newtons. It's important to note, if the wire is parallel to the magnetic field, then it won't experience a force. You don't need to know why at GCSE. Fleming's left-hand motor rule can be used to determine which direction the force will act on a conductor. In other words, whether the force will make the wire move up or down. Place your left hand like this, as shown, with your thumb and first two fingers all sticking out at 90 degrees to each other. Your first finger represents the magnetic field flowing from north to south. Knuckles are north, fingertips south. Your second finger represents the conventional current flowing from positive to negative. And your thumb represents the movement of the wire, which is caused by the force. Let me show you an example how to use Fleming's left-hand motor rule to work out which way the wire will move because of the force. Point your first finger to the right, aligning with the magnetic field flowing from north to south. The conventional current is coming out of the screen, so point your second finger in the same direction, away from the screen. This leaves your thumb pointing upwards, so that means the force is going to make the wire move upwards. Here's one for you to try. Pause the video and see if you can point the fingers of your left hand in the correct directions to work out which way the wire is going to move. Here's the answer. The magnetic field is going north to south from left to right. So point your first finger from left to right. The conventional current this time is going into the screen, away from you. So point your second finger away from you. This leaves your thumb pointing downwards. So that means the force is going to make the wire move downwards. The last thing I'd like to point out to you is that if you reverse the current, this reverses the movement. And if you reverse the magnetic field, that also reverses the movement, as shown here. This is often asked as an exam question. Finally, try not to dislocate your shoulder when using the rule, or hurt anyone else with these crazy Fleming fingers. I hope that's been useful for you. There'll be lots more 3D animations coming up in future videos. Thank you very much. Work hard and be nice. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Bye for now.